Important to know what they mean when they say angle of elevation or angle of depression. These angles are measured in relation to the horizon. So if this is like the horizon, and if you are over here, and I'm drawing an eyeball, okay? If you are looking, so if you're looking straight out into the horizon, looking straight ahead, and if you were to then look up from that, so like up into the sky, then that would be an angle of elevation that you would be using. Your angle of elevation would be this angle measure that you're looking up from the horizon. So your line of sight in relation to the horizon, if you look up, is elevation. Now, if you were to look downward, then that would be the angle of depression. For some of the problems that we're going to be doing, we might use both angle of elevation and angle of depression. It just depends on the situation if you're looking up or if you're looking down. So here would be like a demonstration for angle of elevation, and this would be your angle of depression. So if you're looking up, it's an elevation angle. If you're looking downward, it's depression. Now keep in mind that's with the horizon. So in this picture, here we have a boat and we have a lighthouse. And if you're on the boat, then you know your horizon is like this. If you're up here in the lighthouse looking, then this is the horizon. These lines are parallel with each other because it's the horizon line. It's supposed to be just like straight out from where you're at. They're parallel, and that's important to know. So I'm going to mark these as being parallel. If I were to connect, pretending like you're up in this lighthouse looking down at somebody in this boat with a line, then I want you to notice that we've got some angles formed, and with these parallel lines, we have some alternate interior angles. This is the angle of depression from the lighthouse. Here would be the angle of elevation from the boat. These would be alternate interior angles and would be congruent to each other. So I want you to know that the angle of elevation here is the same as this angle of depression. So if you're given a question and you don't like how your triangle was formed, you could sort of move these angles interchangeably to fit for your needs. So I'm going to draw in just so you can see what I'm talking about the triangles. Here is a right triangle on the top, if I were to draw a vertical line up from the person in the boat. And then this lighthouse forms the other right triangle with the horizon on the bottom. So you can see that I've got two right triangles, and these right triangles are the same because they have these angles that are the same, this angle of depression here and this angle of elevation. They share the hypotenuse. They've got a right angle. So we've got these triangles that could be congruent. We've got this height here and then this height here. So it would be angle, angle, side actually would be what I would use most easily here, because a right angle and this side. So that's how angle of elevation and angle of depression are related, and we'll be using them in some problems.